All right, we are back at it talking about absolute value functions. So in the video right before this, we were looking at graphing the base graph of an absolute value function. Now we're going to talk about moving that graph around a little bit. So I am at a free site called Desmos, desmos.com. There's also a super handy app. I love using it on my phone, tablet. So highly encourage you to kind of walk through it as I walk through it with you. So maybe have it open. So go ahead and click on Graphing Calculator in Desmos, and we're going to use that together to first get a base graph of our function down, and then explore how we transform or move that graph around a little bit. So I'm already signed in. You can sign in with a Google account or make a separate Desmos account. But the nice thing about signing in is then it's really easy to save all your graphs. So I'm going to start typing in good function notation, f of x equals, and let's just get our base graph of absolute value plotted. So like most calculators, there are some syntax shortcuts, but I'll show you first from this keypad. You can pop in here and there are absolute value bars, so you can just use those. I'm going to type in absolute value of x, and then I'll hide the keypad so you can see a little better. The other option, just real quick, would be you can actually type in the word ABS for shorthand absolute value, and that would also produce the absolute value graph. So either notation for absolute value works well in Desmos, whichever is more comfortable for you. And let's see, I'm going to keep my base graph in blue. You can adjust the color of your graph and all of that, so it's kind of fun. And I'm going to make it a little darker. Projector mode just makes the line a little thicker. And let's go ahead and save this so that I can share this exact Desmos sheet with you. So absolute value function transformations. All right, so transformations implies there's a change, right? So what I want to explore is how do we take this graph that's showing on the screen, move it left or right, up or down, maybe reflect it, turn it upside down, maybe adjust the slant, right? Make the V narrower or wider. So how do we do all of that? The beauty of Desmos is we can dynamically explore these types of changes much faster than we could if we were graphing simply by hand. So if I asked you to create an XY table for all of the functions I'm about to try, it would take us so long. So I'll give a little bit of direction to get us started. Let's say that we want to take the same absolute value function, but we want to see what happens. Oops, I'm not sure what I just did. We want to see what happens if we add a value, let's say inside the absolute value. So I just want to add a number. So I could pick a fixed number like 2, but I want to explore more than just 2. I want to look at 3, 4, -5. So I'm just going to use h, right? A letter, right? A variable. So h is holding the place of whatever particular value I want to plug in. Desmos brings up add slider, so I go ahead and say, yes, I want h to be a slider. And what that means is that I'm going to hit the play button and it's going to change the value of h, and I'm going to observe what it does to the graph. So just real quick to orient us to the graph that we're looking at. The blue graph, now the only graph that's showing, is the base graph of the absolute value function. And we learned how to plot that. So you see familiar points like 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. And then I'm going to turn back on this green graph where we're going to explore what happens if we were to add or subtract a number inside the absolute value bars. So you might already have some conclusions drawn from what you're seeing, but let's go ahead and watch this play out. So the green graph is changing in h value as we watch. So h is currently positive, 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 negative. So I'm just keeping an eye on the slider value here and watching what that green graph does. And you can adjust the speed of the green graph in case it's a little overwhelming. You can make it go slower or faster. I'll slow it down just a tad more. So right now h is positive, 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 negative. Now it's negative. So what is the value of h doing to the graph? How does it change the blue graph? How is the green graph different from the blue graph? How would you summarize the change that h makes to the base graph that we see in blue? And perhaps some of you are saying, well, it appears to move the graph, right? It doesn't seem like the shape of the graph, that V shape, it doesn't seem like that's changing. It's more like the graph is literally being picked up and moved, right? And I think we could summarize that motion as horizontal motion, right? It's moving left and right. What's interesting is the left and the right correspond to h being positive or negative. So right now, the green graph, I'll pause it here, has an h value of -4. But notice the green graph is to the right of the blue base graph. What happens if I take that h value and make it +4? Then the green graph hops over to the left side of the blue graph. So if we were to write out in words the effect that h has on this graph, that would be a good exercise to process all that we just did. You can add a little note in Desmos so that you can just type words instead of equations. And I'm going to make a note so that we can use this Desmos document as a way to go back and remember how we transform the graph. So h, we're saying, appears to move the graph. What would we say, left or right? So we could say it's horizontal shifting, right? And then we notice that if h is negative, the graph actually shifts to the right by h units, right? And then if h is positive, the graph shifts left by h units. So I'm writing that out. Take a minute if you want, pause, make sure those statements correspond with what we saw, because this is actually extremely useful. Transformations apply not only to absolute value graphs, but to all the other functions we're going to look at. So it's worth a little bit of time to make some sense of this. So you guys agree right now h is +4, right? And the graph is shifted to the left 4 units from where the base graph would have been. The base graph passes through 0, 0, where that V hits the base, right? But now in the green graph, it's shifted 1, 2, 3, 4 units left. So that's what we mean by saying that if h is positive, the graph actually shifts left. Let's make h negative again. So I'm going to make h -4. Now we can see the graph has moved 4 units to the right. So that's a little interesting, right? The sign is kind of flip-flop of what you might think. So that's pretty cool. We now understand a little better how to take a graph and move it left or right, how to actually pick that graph up. We aren't changing the shape of the graph, but we're just actually shifting it left and right. So what other types of transformations would you like to be able to do? I think I heard some vertical transformations, right? Some up and down. So what I'm going to do is, in Desmos, it's super convenient. I can just turn off the green graph now. So we will temporarily stop exploring horizontal motion. And just so that what we're currently doing is right underneath our base graph, I'm going to make a little space. I'm going to copy our base graph. And this time, let's try throwing a value, any number on the end of the function, like outside of the absolute value bars. So I just want to pick another letter. I'll use k. I'm going to say, yep, I want k to be a slider so that k can take on various values, right? So it's not just a fixed value. And let's see, I feel like making, what was our last graph? That was green. So let's do orange. Cool. So now we have an orange graph. And again, I'm going to slow down. The default animation speed is fairly quick, so lest it be too overwhelming, let's slow it down. Feel free to speed it up if you like crazy things. And I'm going to go ahead and play the new orange graph, which has a value of k. And see if you can make some observations about what k does, and then even more specifically, what a positive k does versus what a negative k does. So we'll just watch this for a moment. So what are your thoughts on this k value? What is k doing to make the orange graph different from the blue graph? Feels very similar to what h was doing in the green graph that we just looked at, right? H was doing this kind of motion, so now k is doing this kind of motion. So now we're looking at vertical motion. And if k is negative, does the graph go lower or higher than the base graph? K is negative right now. Let's pause it real quick while k is negative. Let me make it a little bit more negative. So here's k being -1. All right, let's make it -3 just to make it a little bit more dramatic. So if k is -3, the orange graph, right, the transformed graph is below the blue base graph. So a negative k seems to correspond to a downward shift. Let's just test that theory by taking the negative away and looking at +3. So now +3 sent us above the base graph. So feel free to, again, pause, explore a little bit on your own, but I'd like to write a little statement again, similar to what we did for the green graph, about what this value does. So feel free to kind of copy and paste. I'm going to grab what we wrote about h and see if we can adapt that language to what we want to say about k. And you do have to add it as a note for it to just appear as normal text. So sorry about that. All right, so now we want k. K appears to move the graph, we're saying up or down. Up or down, which would be considered a vertical shift. If k is negative, the graph shifts down by k units. If k is positive, the graph shifts up by k units. So again, pause a little bit here, write those statements down for yourself using your own words. Make sure you agree with the summary that we're getting for the value of k. If this is making a little bit of sense, that's amazing, because like I said earlier, these transformations are true for every category of function. It's not just for absolute value functions. So it's very worthwhile. If it's not perfectly clear yet, that's okay too, because we'll get to explore these transformations when we visit other types of functions. So we're going to be looking at polynomials and rationals and exponentials and logs. And we will see this h and k idea happening again. So it's common to let h refer to this horizontal type of shifting and k to refer to this vertical type of shifting. So for those of you in a previous algebra class, you've likely looked at quadratics. I'll take a small break here and graph a quadratic with you. How many of you are used to ax minus h squared plus k type of equations? You've seen parabolas like this, right? And we're used to h, again, just moving that parabola left and right. So I'll go ahead and go find h and let h play for you. Oh, there it is. So the parabola, still just like an absolute value function, it's just moving left and right. And then if I play k, it's going to move up and down. So probably most of you have seen this type of transformation with quadratics. Maybe it wasn't really introduced using that wording, but you've probably explored different, finding the vertex of a quadratic or a parabola. Neat. Well, let's go ahead and call it quits. I know that was a lot of information. we'll do a separate video where we explore a little bit about how do we take the absolute value graph. Let me go back to the absolute value graph since that was our focus here. So my follow-up question that I'd like you to start thinking about is how are we going to take that graph and make the V shape actually change in narrowness, right? Make it more steep, more narrow, or make it wider. So we'll look at that in the next video.